Well, you ready for some quadratic equation word problems? I thought so. That's spicy water. All right. The daily high temperature in Death Valley, California in 2003 can be modeled by this equation, where T is temperature in degrees Fahrenheit and D is the day of the year. What is the maximum temperature in 2003 to the nearest degree? So if we're thinking of this like coordinates, uh, D would be like our X in this case, which is the day number. Whoa! And then the Y, which in our case would be T, would be the temperature. So let's think about what this parabola would look like if we were to graph it. It's a negative A, so it would be an upside down parabola, and it's wide, it's compressed vertically. So we're looking for when it reaches its highest point, which would be the vertex. So really all we have to do is figure out the vertex. And the vertex formula in standard form here is the one where it's negative b over 2a. That'll give us the x-coordinate, which will tell us the day, and then we can substitute that back in and figure out what the temperature was on that day. So let's figure out our x-coordinate. Opposite of b, opposite of 0.657 over 2 times a, which is that negative 0.0018. Toss it all in your calculator, work it out, and it comes out to 182.5. So the 182nd and a half day is when it reaches its absolute hottest temperature. So to figure out what that temperature would be, we just take this and substitute it right back into the formula. T of 182.5 equals, this might get a little scrunched. Let's see, negative 0.0018 T squared. I'm going to make myself smaller. Scooch this over. Maybe. There it is. It'll get over there eventually. All right. Then we got plus 0.657 T, 182.5. And then the plus 50.95, 50.95. Our calculator does the rest of this work for us. Just make sure you square the 182.5 first before multiplying it by that negative 0.0018. So I have these numbers written out just to make this a little easier. This comes out to negative 59.95 plus 119.9.90 if we're rounding to the hundredths like I did over there, plus the 50.95, which gives us a temperature of, I think it's like 110.9. So we'll call it 111 degrees Fahrenheit. So typically you are looking for either the vertex or it might, you might be able to find this distance, but it'll want like the full distance. Like if you're throwing a ball, it'll be like, oh, well, you can find the halfway point, so just multiply it by 2 to see how long it would take to hit the ground. So these are the types of questions. The function a of x equals negative x times x minus 10 describes the area of a rectangular flower garden where x is the width in yards. What is the maximum area of the garden? So again, this is in intercept form. So if we picture the graph in our head, remember intercept form tells us the a is negative, right? So it's an upside down parabola. And the two intercepts would be at 0 and positive 10 because it says x minus 10. So it would cross here at 0 and it would cross here at 10. And it's an upside down parabola, so it might look something like that. So we need to figure out the maximum area. So it's going to be at its highest right in the middle, right between 0 and 10, which, come on, what's in the middle of 0 and 10? 5. So that's where it's going to be at its absolute highest, when x equals 5. So let's sub it in. A of 5 equals the opposite of x, so negative 5 times 5 minus 10. Negative 5 times 5 minus 10 is another negative 5, and negative 5 times negative 5 is positive 25, and we're talking yards. That will be the highest value. Now, if this was a coordinate, it would be 5, 25, right? If we were graphing it, this would be our vertex. A bald eagle. I don't know why they have to say it's bald. I would just say hairless. A hairless eagle snatches a fish from a lake, flies to an altitude of 256 feet. The fish manages to squirm free and falls back down into the lake. Lucky guy. Its height h in feet can be modeled by h of t equals 256 minus 16t squared, where t is the time in seconds. How many seconds will the fish fall before hitting the water? Now the water is at 0 feet. So we could take this h of t and substitute in 0. Because we're looking for when it hits the ground. Now, luckily, last week we practiced solving by factoring. These are both perfect squares. 256 and 16, we could square root them. So this would factor to square root of 256, I believe, is 16. Yeah. And the square root of 16t would, or 16t squared would be 14. So we'd have 16 plus 4t and 16 minus 4t. Now, if we were to solve each one of these parts, we could say 16 plus 4t equals 0, and 16 minus 4t equals 0. And then if we were to solve these, let's see, here we would subtract 16. 4t equals negative 16. Over here we do the same thing. Now t in this case means time in seconds. So when we divide negative 16 by 4, we get negative 4. Are we going to say negative 4 seconds? No, that's in the past. Forget it, it's in the past. Over here, if we divide by negative 4, it comes out to positive 4. So this will be our only answer. So we'll just say 4 seconds. Now, for the rest of these problems, we are going to use this general projectile function. It's this negative t squared, negative 16t squared, plus vt plus h. V is the velocity, and it always tells you like an upward velocity of blah, blah, blah per second. The negative 16 is always there, and then the h at the back end is kind of like the starting height. And a lot of times it's like, we're kicking a football from the ground, so the starting height would be 0. Or, like if you're throwing a football, it might say the starting height is 5 feet, because it's coming off your shoulder at 5 feet. So we're just going to drop stuff in and solve it. A soccer ball is kicked from the ground level, so that height at the back end will be 0, with an initial vertical velocity of 32 feet per second. After how many seconds will the ball hit the ground? Now, you kick a ball, and ideally it goes up and comes back down. So we're starting at 0 feet, and we're ending at 0 feet. So if we were to sub in our information here, the height we're looking for is 0 feet. 0 equals the negative 16 is always there, plus our velocity is 32 feet per second. So 32t plus our starting height, and again it was kicked off the ground, so our starting height is 0. Now we don't need that plus 0 at the end there. If we were to factor a common factor, I see we'd have to factor out a negative 16, well, a negative, And then 16t is a common factor here. So negative 16t times t would give you the negative 16t squared, and negative 16 times negative 2 would give you that positive 32t. So if we were solving each part of this negative 16t equals 0, divide by negative 16, and you get t equals 0, which is talking about time. So it's saying at 0 seconds it was on the ground, and you're like, yeah, we knew that already because we kicked it from the ground. And then this other part, t minus 2 equals 0. You add the 2, and you get t equals 2. So this is when it hits the ground again. So it would be in the air for 2 seconds. These problems are very similar. You're going to do a lot of repeats on this. A football is kicked from ground level. Again, the starting height is 0, with an initial vertical velocity of 48 feet per second. How long is the ball in the air? So if we drop it in, we're looking for when it hits the ground again, negative 16t squared. The only difference here is the velocity is 48 feet per second, so plus 48t. We don't need to put the plus 0 at the end, unnecessary. So if we factor out, again, 16 goes into 48, so we can factor out the negative 16t, which would leave us with t minus 3. Solve each part of it. Here, t would equal 0, which again means at 0 seconds the ball is on the ground. Makes sense. And here, t minus 3, that t would equal positive 3. So at 3 seconds, it hits the ground again. Again, picture the parabola like this would look like this. Now here it is at 3 seconds. Here it is at 0 seconds. If it said like, when will the ball be at its absolute highest, it would be at the highest right in the middle, which would be at 1.5 seconds. And then if it said like, well, what height would it be at 1.5 seconds? Then you can substitute this back into the formula and figure that out. But they're just asking how long it's in the air. They're sweet like that. Number 6, the height of an arrow is modeled by this equation. So we don't need to use the general projectile function. Get that out of the way. They gave us a function to use. T is the time in seconds since the arrow was shot. How long is the arrow in the air? Well, we want to know when the height is going to equal 0. Now, eventually we'll learn the quadratic formula, which is another option for a problem like this, but we can factor this. Multiply your first and last, and we get negative 64, which means we're looking for a set that is 63 apart from each other. Factors of 64 that are 63 apart would be 1 and 64. So we can make it t plus 64 and t minus 1. We will try to divide them by the number in front, a, which is negative 6, shoot, I should have factored out the negative first. Hey, thanks for catching that. Appreciate it. I'm going to factor out the negative sign first. I should have done that. And then a minus 4 now. So now we need to add up to negative 63. So it would be t minus 64 and t plus 1. We have to try to divide them by the number in front of the t squared, is 16. 64 divided by 16 is 4. And then this, you kick the 16 to the front, so it'd be 16t plus 1. Now when you're solving these, we talked about this when we did the factor to solve. Here the t equals 4. That makes sense. Positive number. Here you're solving 16t plus 1 equals 0, so you subtract the 1, divide by 16. Now we're talking about seconds here. We're not talking negative 1/16 of a second. That doesn't make sense with our problem here. So we're just going to go with 4 seconds. Nice. We're cruising for the cruising. Oh, a juggler throws the ball in the air from a height of 5 feet. Initial vertical velocity of 16 feet per second. Write a function that can be used to model the height h of the ball in feet t seconds after the ball is thrown. How does the juggler have to catch? How long does the juggler have to catch the ball before it hits the ground? So we're looking for when the height is 0. We got the negative 16t squared. The velocity is 16 feet per second, and the starting height is positive 5. So factoring, I see we got to factor out the negative. I won't forget it this time. Minus 16t minus 5. If we multiply our first and last, 16 times negative 5 is negative 80. So they need to be 16 apart, which would be 24. So let's write this out. T minus 20. T plus 4. We have to try to divide those by the number in front of the t squared, 16. Now both of these can be simplified. 20 and 16, 4 goes into 25 times, 16 4 times. 4 and 16 would reduce to 1/4. So final factored form, let's see, 4t minus 5 and 4t plus 1. So if we were to solve that, 4t minus 5, you would add the 5 first and then divide by 4. Okay, that's positive. Here we would subtract the 1 first, so negative 1, then divide by 4. We're talking time, so we're not going to have negative 1/4 of a second. 5/4, if you divide that, you come up with 1.25. So let's just say 1.25 seconds. Because you probably realistically would not want to say 5/4 of a second. 1.25 works. Last one. A rocket is launched from ground level with an initial velocity, vertical velocity of 176 feet per second. After how many seconds will the rocket hit the ground? Hitting the ground, height is 0. 16t squared, our velocity is 176 feet. And then it's starting on the ground, so you could write plus 0, but no need. We can factor out the negative sign. Also, they have a common factor of 16t. So we will factor out negative 16t, which leaves us with t minus 11. Solving our two equations here, t equals 0, again, which means 0 seconds. Duh, that's where it started. And then here, t would equal 11. So it will hit the ground after 11 seconds. That's it. I hope you had as great of a time as I did.